Good morning and welcome to Mr. McElvarro's Maths World. This is the way it is. Today we're looking at equations with natural base logarithms. So we've solved equations with logarithmic equations to any base. Now we're looking specifically at base e. I write that as ln. Other textbooks write it as log base e. So this one's very straightforward. All we need to do is convert it to exponential form and use our calculator. So here we would say taking exponentiating both sides, simply we remove the ln. Okay, so that's going to equal e to the power of -2. And we go to our calculator and discover that e to the power of -2 is some number. Perhaps someone can do that for me and I'll write it in a little while. This one, what are we going to do about this one? Well, certainly we can make use of the log law that suggests that we can take the 3 out front here. So like that, 0.9. And what we can do now, of course, is divide both sides by 3. So ln x equals 0.3. Therefore, we exponentiate both sides again, and we find that x equals e to the power of 0.3. So just working out the values of that on my Casio, I would press Shift LN to get the e to the power box, and I put in a -2. So -2, and that's equal to 0, therefore x equals 0.135. And you've got to find, you're always, just about always, well you are always rounding these off, so tell the reader how precise you're being. In this case, 3 decimal places. Alright, this one, same procedure, x equals, just cancel what I had before, Shift LN, put in 0.3, press equals, and I've got 1.350 to 3dp. Alright, next set of problems. In example 3, we're going to make use of some fairly basic log laws. You will remember that when we're subtracting one logarithm from another, we can combine them in this way. Oops, ln, that's what the nice doing there, ln2. Now for that to be true, obviously 4 over x must equal 2. So 4 over x equals 2, and we could say 2x equals 4, and therefore x equals 2. That one is done. Okay, now to the harder end of the market. Again, what we're going to do is make use of a fairly basic log law and say this. Therefore, ln x plus whoops, I'm struggling here, 1, I know that's not clear, but we'll just remember that, 2x minus 1 equals ln 5, the natural logarithm of 5. So what we're going to do, we've got no choice really but to expand that, but firstly this is what I will say, x plus 1 in brackets, 2x minus 1 must equal 5. So we've got the usual old quadratic equation to solve, expanding using the FOIL technique perhaps, we will get 2x squared minus x plus 2x, so overall it's plus x minus 1 equals 5. Therefore, 2x squared plus x minus 6, so just subtracting 5 from both sides equals that. And once again, we're going to use, hopefully, the PSN method. If that doesn't work, we could use a quadratic formula. So the product here is 2 times -6 is -12. The sum is +1, and we're after two numbers, sounding like 4 and 3 at this stage, that when multiplied give us -12 and when added give us 1. Okay, one of them's negative, that's what the product is telling us, because a negative times a positive is a negative, and the larger in magnitude must be positive. So it looks to me as though it's 4 to negative 3. That times that is that plus that is that. So we use those two numbers when we're dealing with a non-monic, so when the coefficient of x squared is not 1, to break down the middle term in the following way. And what that enables us to do, of course, is factorise in pairs and hopefully solve for x. So you can see that that plus that's equal to that. All right? So factorising in pairs, so pair them up, we get this. Highest numerical factor there is 2. By numeral wise, we've got x. What do I times that by to get back to there? X. What do I times that by to get back to there? Plus 2. Minus, and what I've got here, the highest numeric factor is 3. What do I times 3 by to get back to 3x? It is x minus 2. Plus 2, sorry. Might surprise you, but a minus times a positive will be a negative. So, now we will notice that what's in brackets is the same. Otherwise we've mucked up. So 2x minus 3 and x plus 2 equals 0. Therefore the rest is fairly straightforward. I'm just solving for x, that's alright. So 2x equals 3 or x equals negative 2. We'll come back and look at that in a minute. And this one for that matter. So x equals 3 on 2 or x equals negative 2. Let's be careful. Is it feasible that we do have two solutions? Well, here's our original equation, and you'll notice that if x is equal to negative 2, we've got a problem here and here. So x minus 2 cannot be a solution. If x is equal to 3 on 2, that can be a solution. So we'd say reject, well, x equals negative 2 does not exist. Okay, and that would be the end of our solution there. Thank you.